Welcome to Math with Malia. Today we're doing Eureka Squared, Grade 7-8, Module 1, Lesson 3, Finding Distances to Find Differences. After this lesson, we're going to be able to describe ways that we can model a subtraction problem and strategies that we can use to subtract integers. For the fluency, we're going to use number lines to look at addition problems and adding negative integers. So for number 1, you can see we have positive 8. So we started at 0 and we went to the right 8. If it's positive, we go to the right. Then we added negative 4. So if we're adding negative 4, we start from where we left off at 8 and we go to the left because negative on our number lines means we move to the left. Where do we end up? Well, we end up at positive 4. Okay, for the second one, again, we start at 0 and we add 6. So we start with positive 6 moving to the right. And then we add a negative 6. So that means we start where we left off at positive 6, move to the left since it's negative. Where do we end up? We end up at 0. So we can use these number lines and arrows with directions going to the right or to the left to help us with adding negative integers. All right. Here is a subtraction problem. We have 10 minus 8. What are ways that we can describe this expression? We could say 10 subtract 8. We could say 10 take away 8. These might be some phrases that you've heard in math, but we want to look at how it relates to distance on a number line. So again, like we did in the warm-up, we moved to the right 10 first, and then we moved to the left 8. Since it's negative. So when we're looking at integers, the sign right in front of the integer belongs with that integer. So you should think of that as a positive 10 plus or with a negative 8. So if we look at these integer problems, let's see if we can find a pattern. So we're all starting with 10. We're all starting with positive 10. And here's our first one where we had 10 minus 8. And we end up at positive 2. What if we move to the left 9 places? Well, then we'd end up at 1. If we moved to the left 10, we would be back at 0. If we moved to the left 11, where would we be? Can you see a pattern here in this row? Every time we moved one more to the left, our ending place moves one more to the left. So we're decreasing by 1 every time, right? We decrease by 1 every time. So if we subtracted 11, if we moved to the left 11, we would end up at negative 1. And then following our pattern, we would move to the left one more time. So when we subtract 12, we should end up at negative 2. So let's use our number line to look at this subtraction problem, 10 minus 8. Well, we're always going to start at 0, and since it's positive 10, we're going to move to the right 10. So draw our line moving to the right 10. Okay, that's where we end up. And then we have a negative 8. Remember, if it's negative on our number line, that means we move to the left. Negative means we move to the left. So starting where we left off at 10, we're going to move to the left 8. 1, 2, 3, 4, 5, 6, 7, 8. And we can see we do end up at positive 2. So when you're doing your number lines to do subtraction problems, make sure you're starting at 0, and then if the number is positive, you move to the right. If the number is negative, you move to the left. Okay, let's use our number line now to talk about an unknown addend. Remember, an addend is a number that you are adding to another. So for number 2, we have our subtraction problem that we've been looking at, 10 minus 8. Let's first plot those 2 points on our number line, those 2 values on our number line. We have 10 and we have 8. I'm ignoring the negative right now. I'm just looking at the integers. What's the distance between those 2 points? From 8 to 10, we have a distance of 2. Now, if we're doing our unknown addend equation, we're going to read the equation in reverse order. So 8 plus, because it's an addend, we're adding a number, so we're going to be writing an addition equation. And it's unknown, so we don't know what I'm adding. What number do I add to 8 to get to 10? Well, I think you can do that. It's how many units away? It's 2 units away. So the unknown addend that I need to add to 8 to get to 10 is 2. All right, let's look at the next one. We're starting at 8 and 10. What's the distance between those points? 2 again. And now we're looking, if I start at 10, what do I add to equal 8? So what is my unknown addend? So now I'm starting at 10, and I need to go back 2. So if I'm going to the left, my addend needs to be negative. So I'm going to add negative 2. So my unknown addend here is going to be negative 2 because I had to move to the left. Okay, let's look at the next one. I am starting from 10, and then, do you see it's negative 8 in parentheses? So I do have a point at negative 8. What is the distance between those 2 points? From negative 8 all the way to 10, if we count the steps, it would be 18 steps. So 18 units away on the number line. Now let's write our equation, our unknown addend equation. We start with the end number. The end number is negative 8. What do we add to negative 8 to get to 10? What is our unknown addend? Well, to get all the way up to positive 10, we have to add 18. We're going to the right. Okay, let's do the last one. Again, we have a negative integer in parentheses. So now our numbers are at negative 10 and at positive 8. So there's our 2 points on our number line. What's the distance between those 2 points? It's still 18 units away from each other. Now when we write our unknown addend equation, again, we start with the second number. The second number is negative 10. What do I add to negative 10 to get to positive 8? I have to add 18. And I'm going to the right. So here you can see where we started with positive 8. And then how do I get to 10? What do I have to do to get to 10? Well, I have to add 2 more. I have to add 2 more to get to positive 10. So my unknown addend is 2, positive 2. All right, for this one, we started at 10. So we started at positive 10. What do I have to add to end up at positive 8? What do I have to add to end up at positive 8? This time I have to move to the left 2 units. So if I move to the left 2 units, I have to add a negative 2. My unknown addend is negative 2. All right, we have a few more unknown addend equations to work on. We already have the distances here, so I'll draw them on the number line. We have negative 10, and then we're going to positive 8. The distance is 18 between those 2 points. And then we're going to write our unknown addend equation by starting with the second number. We're going to go in reverse. So 8 plus what addend gets me to negative 10? Since I have to go to the left, if I'm starting at positive 8 and I need to go to negative 10, I have to go to the left. So I need to add negative 18. So my unknown addend is going to be negative. Okay. For the next one, we have negative 8, and then we're going to positive 10. The distance is still 18. Let's write our unknown addend equation. If I'm starting with 10, what do I add to end up at negative 8? Again, I'm starting at 10. I have to go to the left to get to negative 8. So my unknown addend should be negative 18. Okay, number 8. I'm starting at negative 8. And I'm going to negative 10. What's the distance between those 2 points? 2 units on our number line. So if I'm starting My unknown add-in equation, I start with the second number, which is negative 10. What do I add to negative 10 to get to negative 8? Well, I start at negative 10. I have to add to the right. So this is going to be a positive 2. My unknown add-in will be positive 2. Okay, and our last one, we have negative 10 and negative 8 again. So the distance between those two on the number line is still 2 units. But our unknown add-in equation will look different. Our second number is negative 8. What do we add to negative 8 to get to negative 10? This time, I have to go to the left. So if I'm moving to the left, I know my add-end needs to be negative. So my unknown add-end would be negative 2. So here you can see it again with our number lines. We started at 0. We went to negative 8. That's our first number. And then we added to the right in blue to get to positive 10. We had to add 18. For number 5, we still started at 0 and we moved to negative 10. And then we want to get to positive 8. It's still moving to the right, so we're going to add positive 18. So I want you to remember, anytime you see a negative sign, it means the opposite. Negative doesn't mean subtract or take away. It means do the opposite. So, in this case, the opposite of negative 10, what is the opposite of negative 10? Well, the opposite of negative 10 is positive 10. If I do 8 plus 10, what do I get? I get 18. So, the unknown add-in equation will help you to subtract negative integers. Okay, for number 6, we started at 0, we moved to the right to get to positive 8. Now we need to move to the left to get to negative 10. Since I'm moving to the left, my add-in has to be negative. So my unknown add-in is negative 18. That means if I do negative 10 minus 8, I should get negative 18. You can think we move to the left 10 units, and then we need to move to the left even more, 8 more units. So I've already got to negative 10, and I keep going to the left 8 more units to get to negative 18. Number 7, we started at 0, we moved to the right to get to positive 10, and then to get to negative 8, we have to move to the left, so that means our unknown add-in will be negative 18. Again, I move to the left to get to 8, and then I move to the left 10 more times. So I already started at 0, I go to the left 8, and then I go to the left 10 more times to end up at negative 18. So some different ways you can think about subtracting integers. Number lines can be very helpful. Just remember, if the integer is positive, you're moving to the right. So here, we're moving to the right. If the integer is negative, you're moving to the left. So then you move to the left. All right, we have 2 negatives in a row again. What does a negative sign mean? The negative means the opposite. So what's the opposite of negative 10? The opposite of negative 10 is positive 10. So we could rewrite this problem as negative 8 plus 10, because the opposite of negative 10 is positive 10. So we moved from 0 to the left to get to negative 10. I need to get to negative 8. That means I move to the right. I have to move positive 2. So our answer is our unknown add-end. You could also just think, if I move to the left 8 here, whoops. This says move to the left 8, and then this says move to the right 10. So then you went over 0 and then 2 more. All right, last one, we start at 0, we move to the left to get to negative 8. We have to keep going to the left to get to negative 10, so our unknown add-in should be negative 2. Again, that means our solution is negative 2. And if we have a negative, that means the opposite. So the opposite of negative 8 is positive 8. So negative 10 plus 8 should be negative 2. I moved to the left 10, and then I moved to the right 8. I didn't quite get back to 0. All right, number 10. Let's look and see if we can find a mistake. 32 minus negative 45 equals 32 minus 45, and then the sum would be negative 13. So what did we miss? Well, remember, negative means opposite, so this means the opposite of negative 45. The opposite of negative 45 is positive 45. So really, this should have said 32 plus 45. And what is 32 plus 45? 32 plus 45 is 77. Sea level is represented by 0 feet. I like to draw vertical number lines when I'm talking about sea level. So here's my vertical number line, and I'm going to put 0 right in the middle. Sometimes I like to draw water here too to make me remember that sea level where the water is. Again, at Bird is at an elevation of 28 feet. So 28 feet, that is a positive integer. That's positive, so that means I'm going to be above 0. So let's make a tick mark up here for 28 feet. It dives straight down to an elevation of negative 19. So this integer is negative. That means it's going to be below 0. So down to negative 19. Might not be to scale, I'm just estimating. How many feet does the gannet dive? So here's our vertical number line, and we need to find the distance from this point where it started to this point where it ended up. What is the distance between those 2 points on our number line? So we started at 28. What do we have to add to 28 to get to negative 19? What do we have to add to 28 to get to negative 19? Well, we know we have to go down our number line, or we're moving to the left, so it has to be negative. We're going to be adding a negative number. And we know to go from 28 to sea level would be negative 28, right? And then from 0 to negative 19, that's another negative 19. So we could add those two together and get a negative 47. So we're adding negative 47 to go from 28 to negative 19. For the debrief, let's look at our problem 10 minus 23. Okay. We start at positive 10, and then we're going to move which direction? With negative 23, we're going to move to the left. So we start at 10. Here's 0. We start at 10. And then we're going to move to the left, 23. So there's 10 to get back to 0. And then I need another 13 to get to a total of 23 to the left. So if I went 13 more, this would end up being at negative 13. So remember, the numbers have signs right in front of them. So whatever sign is in front of the number that belongs with that integer, they stay together. Negative means it goes to the left on our number line. Positive means it goes to the right. And one more thing I want you to remember, negative always means opposite. Opposite of whatever comes next. So if I were to write negative 23, what's the opposite of negative 23? The opposite of negative 23 is positive 23. It tells us which direction we're moving on our number line. All right, do some practice problems, and if you have any questions, leave them in the comments and come back for lesson 4.